Hey guys, it's Chili here. I'm coming back at you with another beginner SFML tutorial. That just rolls off the tongue, don't it? Anyways, so today we're going to be looking at how to draw a basic animated sprite, a walking sprite. And first thing I just want to say is that for those of you waiting for the intermediate videos, they're coming. They're in the process of being recorded and edited, and I'm going to be getting some of that shit out very soon. But I thought I'd put out some other content just to tide you guys over. So, I hope you've watched my setup tutorial for SFML, 2 ways to set up NuGet or VC package. I am going to be going on the assumption that I installed VC package, so I'm going to be using that workflow. So we're going to create a new project. I'm just working in Visual Studio 2015 here, by the way. I'm going to create a new project, and the empty project, yeah, we can make an empty project. It doesn't really matter that much. And I'll call this one SFMLBS. No, we'll call this one SFML Sprite Anim. And we'll start her up. And let's add a new item. CPP file, source.cpp, that's fine. All right, now what I'm going to do is I'm just going to, again, copy this example code that they have here, because that seems to be enough to get us started. Make sure that nothing goes wrong here. Let's see if it builds. It should build because I have done the VC package installation, so I don't have to worry about headers or anything. It'll just work. All right, now this thing is loading an image and displaying it, playing some music. We don't want to play music. We don't want fonts. So let's get rid of all this bullshit from here, and not drawing the text, so we'll get rid of that. And now we got to change the name, so we need a sprite. So what I'm going to do is I'm going to use this animated sprite here. You can use whatever the fuck you want, I don't care, but I'm not giving you a sprite because I don't have a sprite I can actually distribute or anything. So let me show you what the sprite looks like. It looks like this. Professor walk cycle. It's a nice walk cycle. It's got quite a few frames of animation. I think it's got 8 frames of animation per cycle here. That's pretty good. And then there's a standing cycle here. It's not a cycle, it's just a frame, a standing frame. So what I'm going to do is I'm going to go into the folder for the project, and we'll drag this one into here. Professor walk cycle, no hat. We'll copy that, and we'll hope that fucking Visual Studio redraws its shit. And we're going to paste that into here. And so now if I build, no, I've already built it. No, I got to build it again because I changed the name. That's correct. If I run it, I should see the professor on the screen. There he is. The professor is on the screen. We've got all the frames of that animation there drawn. Now, what we want to do is we only want to draw one of those frames of animation at any given time. So how do we do that? Well, now we go into our sprite. Let me just open this up again because I'm going to be needing it in a second. I'll move it to the side here. So we go into our sprite, and we go set TextureRect. That's what it's going to be. And this one sets the sub-rectangle in the texture, in that image that we want to draw. And this takes an int rect. I don't know what the order, I mean, it's a rectangle, right? It's going to have 4 components. I don't know what they're going to be. I would assume left, top, right, bottom, but I'm not sure. Now, let's look at the professor again. Now, let's not look at that. Let's look at the properties of this file. And we can see that the dimensions are 576 by 256. Now, remember, there are 9 frames across on that dude. This is important. So there are 9 frames across. And let's just go into here. So if we go 576 divided by 9, what do we get? 75.1. That's, well, first of all, that's a 6. So let's learn to type. And then let's try that again. 64. And if we get, so it's every frame is 64 pixels wide. And we know that there are 4 cycles. So 256 divided by 4 is also 64. So our frames are 64 by 64. And they're nice and evenly spaced out, and that is going to make our life a lot easier. A lot of sprites you find online, they aren't going to look like that. They're going to look maybe like something, well, this one's actually not too bad. This one's pretty good. It's pretty regularly spaced. But a lot of them are not going to be regularly spaced, and you're going to have to figure that shit out for yourself. Easiest is if you can find one that is already nicely spaced out. So it's 64 by 64. So what we can do is we can go 0, 0, 64, 64. And so we set the texture rectangle, and then if we draw this, now we see we got our dude. He's facing the wrong direction. I guess that's all in your perspective, but yeah, we're drawing now one single frame of that animation. Now it looks like a character is being drawn on the screen, not a sprite sheet. That's a step in the right direction. Now, what we want to do is we want to create a class to represent our character. All right, so let's go ahead and we'll just create a class in the same file because I don't give a crap. This is just a little demonstration here. Character. And by the way, this isn't like me saying, this is exactly how this should be done. This is the optimal solution to this problem. I'm just giving you some ideas here. Private. I'm giving you some ideas, a little bit of a recipe that you can kind of, get your own ideas from and then make your own thing. And that's my whole philosophy, right? Is, teach a man to fish as opposed to just giving him a fish. So I don't want to just, give you all the fish, explain to you every little task that needs to be done to make a game. I want to teach you how to fish. I want to give you the base skills, and then hopefully you can then catch your own goddamn fish. That being said, it's always good to know what a fish looks like if you're going to go fishing. So that's why I want to make, little videos like this, giving you some little recipes, some ideas, and then your own creativity can kick in, and you can use the skills, hopefully, that I give you in the main series to come up with your own shit. So, this is just an idea of how this might be approached. Don't take this as the best solution ever. So what we want in our character here is we're going to give him a sprite. We're going to embed a sprite into him. And we'll just call it sprite. And we'll also give him a texture. So SF Texture. And Texture. There we go. Now our character is going to need a position on the screen. Now, normally what I do is I like to use my own custom vector class, not because I don't want to use anyone else's shit, but because, well, SFML, their vector class is kind of lame. It doesn't have very many useful functions in it. So I generally use my own, but we don't have that right now. So we're going to use the SFML vector class, which is, I believe, vector2f. And we'll use that for position, and we'll get another one for velocity. And I believe this is going to be enough for us to start. Now, what functions are we going to have? Well, we're going to have a character, constructor, obviously. And what is that going to do? Well, we're going to construct the texture. Actually, I believe texture, it cannot be constructed, like you can't just pass it a file name. You have to call load from file. Let me check. Yeah, there's no way of constructing it from a file name. So we can't do that. And because we can't do that, we can't construct sprite. So what we're going to do instead is we're going to go texture, not load from file. And yeah, we'll just copy this actually. Normally I would do an error check in here like they're doing here, and I would probably throw an exception if I couldn't load the file, but we're not going to do that for a number of reasons. First off, because I haven't really covered exceptions yet in the main series. And second of all, because I don't really want to waste time on that stuff for this video. So just pretend that I'm doing some good error checking in here, and we'll call it even. So we'll go sprite is equal to, and we'll just create a sprite, SF sprite, call the constructor, pass it the texture, and that will set up our sprite. And let's set the texture rectangle in here as well for our character. And the velocity of the character will initially be 0. And the position of the character, actually, we can pass that in as a const SF vector 2 F ampersand position. And this one we can do with the initializer, so let's do that. So we create our character at a given position. Now, what functions are we going to need for this guy? Well, obviously we're going to want to be able to draw that fucker. So draw. And the way we're going to do that is we're going to pass in the window. So what is this? It's SF render window. Actually, render window inherits from render target. So what we can do is we can make this even more general. We can go, no, it can't be constant because it's going to modify it. SF render target. And we'll just call this one RT. And it's a const function because it does not modify our character. And now all we're going to do for this one is we're going to go rt.draw and the sprite. So we draw the sprite to the render target, which is probably going to be the window, but could be something else, like a texture or something. All right, and so we draw. What else do we want to do? Well, void handle. We could do handle input or set direction. Let's do set direction. Erection, more like it. SF vector 2F ampersand dir. So this will set the direction of the sprite, and the sprite is going to move in that direction with a certain velocity. So let's go static const expression float speed is equal to, and we'll give them a speed of 3 pixels per second. That's not enough pixels per second, is it? Let's give them a speed of 3 times, let's give them a speed of 100 pixels per second. And when we set the direction, what we're going to do is we're going to do position, not position, velocity is equal to direction times speed. There we go. So saying direction will set the velocity. And last but not least, we need a function to update the character. And that will take a float dt for delta time. And all that's going to do is going to be position plus and equal to velocity times delta time. Seems clear enough. This shouldn't be anything new to you guys if you've been, following along with my series. No new concepts in here. Now we're going to want to handle some input in here. So how is that done? Well, in the game loop here, so after we've handled the window stuff and before we draw, we'll just do some handle input. So we need a SF vector 2F dir, and we'll set that initially to 0 and 0. And then we're going to want to pull the keyboard and adjust the direction depending on, what happens on the keyboard. So if SF keyboard is key pressed, and we want SF keyboard key, so SF keyboard key. Well, actually, these keys are all just in this namespace here. So the key, let's start with, I don't know, up. Up, there we go. So if key up is being pressed, then we want to do direction plus, well, we could just do direction dot y minus and equals 1. So we subtract 1 from direction dot y. And we can just do this for, again, all the other directions. And if we do that, it should look something like this. And now that we have set up our direction vector, all we got to do is, well, I guess first of all, it would be helpful if we actually created a character. So let's get rid of this bullshit. We don't need this anymore. And let's go character car. No, that's bad. That's a bad name. Let's go character fucker. There we go. Oh, fucker needs a place to live. So let's put the fucker at 50. No, 100. Stop it. 100. 100. There. There's your new home, buddy. Hope you like it. So we create the fucker. And here we are going to set the fucker's direction. So fucker dot set direction dir. And then we want to update that fucker. So we're just going to do, for now, what we're going to do is we're going to go fucker dot update. And we'll just say it's, hard coded 60 frames per second. So 1/60. And then we clear the window and we go fucker.draw window, pass the window to the fucker so he can draw himself to it, and then we display the results. So this should allow us to control the fucker and he'll move around on the screen. We got a moving sprite, hopefully. Let's try it out. Here's the fucker. And let me press the buttons. And the fucker ain't moving. Well, okay, I must have fucked something up. All right, well, I mean, I did something really dumb, but it's understandable. So the problem here is that, okay, great, we're setting our position, we're setting our velocity, we're doing all that shit. But the thing we're actually drawing is the sprite. So if we don't set these position values to the sprite, it's kind of meaningless, all this stuff we're doing. We've got to actually reflect that work in the sprite. So what we can do, we can put this in a bunch of different places. We could put it in the update, but I'll just do it in the draw. So whenever we draw, we also make sure that the sprite is at the right position first. We synchronize the sprite with our actual position variable. And the way we do that is we go sprite dot set position, and then we just pass in a position. And now, now you're mad because of this. Yeah, okay. I can't make draw constant because if I do that, then I won't be able to set position here. There are a few ways we could get around that, but I guess I could just, well, I mean, I do like my const correctness. I'm not going to lie to you. Let me just put this in update. It should be fine in, no. Wait a second. We're experiencing technical difficulties. So we'll update the position. We'll set the position in update. And then this is also bad. We will update the position. Then we'll set the sprite's position based on that. And now if we run this, it should work as expected. All right. Now the dude starts off at 100, 100, which is a good start. And when I use there, oh shit, okay, he's a little fast. He's a fast motherfucker. I'm not gonna lie. I mean, I know I set it to like 100 pixels per second, but this is actually insane. What if I just set it down? don't really get, I mean, if I'm multiplying by 1 over... I understand. So, and this is kind of in the framework. The framework has VSync set up, so it only renders at 60 frames a second on my monitor. But this one does not have VSync set up. I imagine you could set it up if you wanted to, but right now we don't have that, so it just renders as fast as possible. And that's why the dude moves incredibly fast. So for a quick fix, let's set the speed down to 1. So now he moves 1 pixel per whatever. All right, now, okay, that's pretty slow. That's very slow, but we can see the dude is moving. So obviously, especially with this system, I mean in general, but especially with this system, we want to measure the frame time so that we know how much to update the sprite by, the character. So what we're going to do is we're going to do basically the thing I showed in the main series, which is we're going to use the chrono library to get the time. I'm not going to create a separate class for it though, not for this. So we'll go chrono, and where should we put it? In here, time point for delta time measurement. So we're going to get a time point that will be used to keep track of the time elapsed between frames. So we'll go auto TP for my bunghole and std chrono steady clock now. So that'll get a time point. That'll start off the time point here. And then every frame, what we want to do before we handle the input, get dt. So we're going to create a float dt. And in here, so we'll copy this. We'll paste it in here. We'll go const auto new time point is equal to std chrono steady clock now. And then we'll do dt is equal to std chrono duration float, and that's going to be what's it going to be? The new time point minus the old time point dot count, and that'll give us the float of the duration. And then we'll go time point is equal to, that's not equals, equal to new time point. So this will get us our dt and it'll update the time point. And then we can pass our dt into here. That's not what we're doing. We're not doing that. We're going to pass our dt into here for the update. And what else do we want to do? Well, now we can set the speed back to what we originally wanted, which is this should now be 100 pixels per second speed, now that we're actually measuring the time between frames. And if we do this, and now we see our dude, well, this is a problem with the capturing. Capturing software is not cooperating today. But you can see that the dude is now moving around with a good speed. It's good. You got automatic clipping. That's all taken care of for you. It's all good. All right, now what we want to do is we want to make our sprite actually walk with an animation. Walk like a man, talk like a man. It's my party and I'll cry if I want to. So what we're going to do is, well, right now we're setting the texture rectangle to, let me just show you, to this one here. What we want to do is we want to, on a timer, we want to cycle that rectangle. We want to set it to be these different positions in the texture, cycling through. Well, if we're walking upwards, we want to cycle through these ones. If we're walking to the left, we want to cycle through these ones and then go back and do it all over again. So what we're going to do is we're going to create another class. We'll call it, we'll just call it animation for now. And that is going to represent one of those animation cycles. So public, private. All right, so how's this going to work? Well, first of all, we got to decide where we're storing the textures and where we're storing the sprite. Now, the way we're going to decide to live our life is we are going to have the animation store the texture. And what it's going to do is going to have a function called apply to sprite. And that will be able to apply a rectangle and a texture to a sprite. And that will set the sprite to be at that frame in the animation. You'll see when we get to that. So we need SF texture. I mean, I could have just copied the one that we had down there. And we need, what else? We need a bunch of things. So we're going to need an array of rectangles, which represents the different frames of the animation. And we're going to need static const expression int n frames. So we have a number of frames. Let's set that to 8. And what else are we going to do here? So now we need, and what is this going to be? SF int rect. Okay, and this is going to be the frames. And there's going to be n frames of them. So it's going to store the rectangles of the frames. Now, what we need is we need integer I frame. So this is going to store the index into the current frame of the animation, the one that we're working with. And we need static const expression float hold time. Put that to 0.1 seconds. So this is the amount of time that a frame will basically be on the screen before it cycles to the next frame in the animation. And then we're going to need float time equal to 0.0f. This is keeping track of the time elapsed until we have to cycle the frame of the animation. So I believe this is all we need. All right, now the tricky part of this is going to be generating the rectangles for the frames. So we're going to have a constructor here, animation. And what's it going to take? It's going to take an int x and an int y. And that's the starting point in the texture here, where we're going to do basically where we're going to be starting calculating the rectangles for the frames. We're going to need a width and a height. Int width, int height of an individual frame. And we're also going to need a std string. Let's make constant. Well, I was going to say, pass in a string for the texture, but let's just hard code that in. But normally you don't want to hard code that in, right? You want that to be a variable. But let's start with this, xy, width, and height. And everything else is hard coded, so, the hold time, the number of frames, etc. All right, so now we can, first of all, let's load our texture. So I'm just going to cut this out of here. Put that into here. Actually, I can get rid of texture from here altogether. So we load our texture. Now we have to go through and set up our rectangles. So we go for int I is equal to 0 as long as I is less than in frames I plus plus. And here what we're going to do is we're going to go frames at I is equal to, and what are we going to put in here? Well, for the x of the left x is going to be x plus I times the width of a single frame. And the top y is just going to be y, right? That's never going to change. The right x is going to be x plus I times, I plus 1. It's the one after I times width. And then y is going to be, the bottom y is just going to be y plus height. And this should be correct if I got the orders right. So here we're setting up the rectangles for all of our frames. And now we need a function to apply this to a sprite. To apply this animation frame, current frame of this animation to a sprite. So we go SF sprite ampersand S. And this is constant because it doesn't affect this object, it only affects the sprite that's being passed in. And for this we go sprite set texture rectangle. And that's going to be frames at iframe. So the current frame in the animation. And we should also set the actual texture itself. Just in case, because you could have multiple textures for a sprite, different textures for different animations. So we'll set texture to texture. So for apply to sprite, we set the texture and then we set the frame. Now we need a function to update the animation. And again, we'll float dt. So what we do is we go time plus and equal to dt. And then while time is greater than or equal to the hold time, which is the time of a single frame, time minus and equals hold time. And we want to advance the animation. We'll create that function later. But why we're doing this as a while loop is if a lot of time passes, if enough time passes for 2 frames to change, then we want to advance the frames twice. So we keep consuming hold time until time is less than hold time. And advance. Now, advance, we'll just put this as a private function. The outside world doesn't need to know about this. Advance. And this is very simple. All we do is if iframe is, we'll just say greater than or equal to n frames, iframe is equal to 0. And we want to do first increment and then do the comparison. And if it is past the end of the array, then we reset it to 0. So there's the advance function. Here is the update function. Here's the apply to sprite. And this should set up our rectangles. So now we've got an animation class. Let's include that into our character. So we go sprite, we go animation. Let's just call this one down walk. Or let's call it right walk. All right, and now we have to actually initialize that. It's an embedded object, so we go into right walk, and what does it take? It takes x and y and width and height. Well, width and height are fixed. I could have just hard-coded those, but I didn't for some reason. So right walk is going to be this one. So the x is going to be 64 times 1, 2, not the x, the y is going to be 64 times 3, and the x is going to be 64. So let's go 64 times 3. The width is 64 and the height is 64. And that should set up our animation rectangles. Now we don't have this anymore, so we do that. Now for the update, we're going to do a little bit more work, aren't we? First of all, we're going to go right walk dot update dt. So we're going to update that animation so it can cycle when it reaches the proper time. And then we're going to go sprite. No, we're going to go right walk dot apply to sprite, and that will apply this animation frame to the sprite, and then we synchronize the sprite's position with the position of the actual character. And then it's going to be ready for drawing. So, and we shouldn't have to change anything here because that just hooks all into the function update that we've already done. So that should be enough for an animation. Let's see if it actually works. Alright, this is a little messed up. I think looks like my rectangle calculation was a little off, as you can see here. This one is actually working fine, but we're also getting these kind of doppelgangers here, and that's no good. Alright, now I realize what the problem was. My assumptions about the constructor were wrong. So the constructor takes 4 ints, left and top is correct, but then it takes the width and the height of the rectangle. It doesn't take the right and the bottom side. So that actually makes our calculations a lot simpler. So the left is just x plus I times width and then y. And then here we just put in width and height. And that, my friends, should make life a lot easier for us. Now let's take a look. All right, now we've got our dude, and he's walking around. He's doing the moonwalk. That's pretty sweet. But we probably want different animations depending on what direction he's moving at. So how are we going to do that? Well, what we can do is we can go into here. We can go private enum class animation index. That's bad. There we go. And let's give ourselves some animations here. So walking up, walking down, walking left, walking right, and last one here, we'll call this one count. And I'll tell you why in a second. So we'll create an enumeration for some animations here. And instead of having a single animation right walk, let's go animations. And we'll go int animation index count. And because animations they start from 0, this will be 0, 1, 2, 3. This one will be 4. So the value of this enumeration will be the count of all the actual enumeration things. So it's a nice little trick. So when we create an array of different animations that we want. And then in our constructor, now, we can initialize those animations. The problem is, here's a problem, and that is that we need a default constructor now because we're making an array of animations. So all we gotta do is go up here, go animation, I keep hitting that J key, is equal to default. And that'll give us the default constructor. So that's fine now. And now we just gotta loop through all these animations. Actually, instead of doing a loop, we should just do it manually. So we'll go animations, and we'll go int, walking up. Oh, we need to do the thing. Animation index, walking up. And that is equal to animation. It's the fucking J key, man. And now we need to put our stuff in. So walking up is going to start with an x of 0, x of 64. The y is going to be 0. The width is going to be 64, and the height is going to be 64. And we'll do this for all 4 animation directions. And if we do that, it should look something like this. Then we can go in here, and we can set an animation index. We'll call this one current animation. That fucking J key, man. Is equal to animation index. And we'll start her off with walking down, I guess. Now, here is the trick. So, well, this isn't the trick. This is the easy part. The easy part is now when we update, instead of calling right walk, we are going to call animations at, we'll cast to int, the current animation. And then we'll update just the current animation, and then we will apply the current animation to the sprite. And that's good. But now we need a way of actually setting the current animation. That's going to be set when we set the direction. So how do we do this? Well, it's quite simple. Like if the direction, the x component of the direction is greater than 0, then we're going to be moving to the right. So we'll just do current animation is equal to animation index walking right. And likewise, else if direction.x is less than 0, then it's going to be walking left. And you get the idea for the other ones, right? And now if we do this, again, like before, we shouldn't have to change anything in the main game loop. Now our dude... No, gotta click the play button, I guess. Now our dude, his animation should change depending on the direction that he's moving in. Pretty fucking sweet, ain't it? Now, if he's stopped, he's just going to be walking because we haven't created any animations or any animations for the single frame of standing still. We could do that, but this video is already getting, pretty long in the tooth. So I think I will just leave that as an exercise for you guys. So the final thing that you want to be able to implement here is you want to be able to implement the situation where he's standing still. And there are a bunch of ways to do that. One little hint, I think the easiest way to do that would be change this from an array to a vector. So I hope this gave you guys a little bit of an idea, a start on how you can implement animation in SFML. And let me know in the comments what you think. If you got any ideas, any suggestions, I'm all ears. And if you got problems, if you need some help, hit me up in the Discord or in the forum, and I will hook you up with some information. Until then, this is Chili, and I will see you soon with some more C++.